Hello. In this video we're going to talk about measures of spread. So the first kind of measure of spread we're going to talk about is the simplest one, and it is called the range. You may have heard of it before. The range is basically the highest data value minus the lowest data value, the highest number minus the lowest number in the data set. It's a pretty basic formula. It's just subtraction of two numbers. Here's an example. In the table below, the average monthly temperatures are listed for each month for San Francisco and St. Louis. So you can see the monthly temperatures from January all the way through December for both of these places, San Francisco and St. Louis. So 51 is not how much the temperature is in every day in January. It's just the average monthly temperature. Okay, so what they want us to do here is they want us to find the range for San Francisco. So we want to look at San Francisco and see what the range of temperatures are here. So we want to find the highest temperature, which I believe is 63. And then we find the lowest temperature, which is 51, and we subtract the 2, and we get 12. So the range of temperatures is only 12. It means that the weather is pretty consistent throughout the year. You can probably have just one wardrobe. It doesn't look like it gets too cold. It doesn't get too hot. Again, 51 to 63, so only a range of 12 degrees. Now we're going to find the range of St. Louis. So we want to find the highest degree in St. Louis, which I believe is 79, and the lowest is, I believe it's 30, and we're going to subtract those two values. So 79 minus 30 is 49. So that's definitely a bigger range. You definitely need a wider range in your wardrobe as far as you need coats, gloves, hats, but also when it's 79 degrees you could probably wear shorts and flip-flops. So the weather is not as consistent there, and that's what the range can tell us. Now, range is fairly easy to find, but it only takes into account two data values. So for all of these data values here for St. Louis, we only considered 79 and 30. Those are the only two values that were considered. So because it only takes into consideration two values, it isn't used in practice very often. So instead we're going to use what is called standard deviation. Standard deviation is the average distance of the data points from the mean or from the center. So basically what you would do to find this is you would figure out what the mean was and then take each data value and find out how far from the mean each of those data points are. And once you find that distance, then you take the average. Now, there's a little bit more to it than that, but we're actually going to use our calculator. You can also use Excel if you were using a computer, but in this class we're going to use our TI-83 or 84 calculator to calculate the standard deviation for us, since the formula is a bit lengthy. The formula itself doesn't look lengthy, but the process is lengthy in finding the standard deviation. We have already found the standard deviation in the past when we worked through measures of center, and we found the mean and the median. So the process for the standard deviation is exactly the same. We're going to go to var stats. Now, when you go to var stats, you'll get your X bar, you'll get your median, but there was many other numbers that it gives you when you go to var stats. Two of those numbers are standard deviations, so this is where you have to be careful. There's not one type of standard deviation. There's two. There's a sample standard deviation and a population standard deviation. Now, there was a sample mean and a population mean as well, but the process to find both of them is pretty much the same. So the calculator only gives us one mean. It gives us an X bar, and it doesn't matter which one we're finding, whether it's population mean or sample mean, the answer is going to be the same. Now, when we get to standard deviation, the process, if you were actually to do it with the formula and by hand, is slightly different for the sample standard deviation from the population standard deviation, which means the two answers you would get if it was a sample versus whether it was a population is going to be slightly different. So you'll notice in your calculator when you do VAR stats that you will have an SX, which stands for sample standard deviation, and then this symbol right here. This is a lowercase sigma. Now in the videos for measures of center, we talked about the uppercase sigma that looks like this, and it stands for sum. But this notation stands for lowercase sigma, and that stands for population standard deviation. So in the calculator, it will be sigma x, and that would tell you what the population standard deviation is. So here's a screenshot in the calculator. At the top, you see your x bar, followed by sigma x, which is sum, capital sigma x, which is the sum of all the numbers. Sigma x squared would be the sum of all the numbers squared. We don't really use those. But then next you'll see SX. So if the data you put in is a sample, then this is the standard deviation, 8.92748, etc. If the data you put in the calculator is a population, you want to use this lowercase sigma x right here, which is 7.98498, etc. So you notice the numbers are close. They're only one off from each other in this case, but they are different. So you want to make sure you choose the correct one. Know which one you're supposed to find. Know whether you're supposed to find the standard deviation for the sample or for the population. So make sure you choose the correct one. So here's an example. We have battery lifetimes in hours for a population of 6 batteries. So we have the batteries 3, 4, 6, 5, 4, and 2. Okay, so I've closed out of the presentation mode so I could pull up the calculator. So let's walk through this with the calculator. Let's find the population standard deviation. So we're going to go to stat, and we're going to enter our number stat and edit. So I'm going to clear this out. This is what we had in for something else. So I'm going to highlight L1 and hit clear, then down. So all of that is deleted. So now I'm going to put in the battery lifetimes 3, 4, 6, 5, 4, 2. Now you can see what the standard deviation is going to be, but I just want to show you how to get the answer. So we're going to go to stat, and then just like we did for mean and median, we're going to arrow to the right and choose calc, which is going to change our menu, and we're going to choose number 1 var stat. So you can either hit 1 or you can hit enter. If it gives you prompts, make sure you tell it where your list of data is. So if your data is in L1, you'll just keep it L1. If it is in another list, such as L2, if you look above the 2 button on the calculator, it says L2. To get there, we do second 2. But I have mine in L1, so I'm going to change that back. Frequency list, just like when we did measures of center, should be left blank. We'll go to calculate. For those that don't have the prompts, just go and hit enter. And we see first off our mean is 4, but we are actually interested in our standard deviation. So again, there's 2 standard deviations. There's a sample standard deviation and the SX, and then lowercase sigma x, which is our population standard deviation. The question asked us to find the population standard deviation. So if you look, the population standard deviation is 1.29099. If you round to 3 decimal places, the 0 looks at the 9 and it becomes a 1, so 1.291. Now, rounding purposes, you just want to pay attention to what the homework or the tests tell you to do as far as rounding for standard deviation. I think usually I have you guys go out to 2 or 3 decimal places for standard deviation. Okay, so let's look at the next slide. Example 1, standard deviation. The ages of 10 fifth grade students are given below: 11, 10, 9.5, 11, 11.5, 10.5, 10, 11, 10, and 9.5. Find the sample standard deviation. Okay, so the answer we're going to get is 0.6999, or I'm sorry, 0.699. To get there, we go to Stat and put our new data in, which is what I've done here. And then once you have your data in, we go to Stat, over to Calc, arrow to the right, choose var stat. And then my list is an L1 again, so I'm going to leave that be. Calculate. And this time they said find the sample standard deviation. Sample standard deviation is the S, so that's 0.6992. If we round it 3 decimal places, it's 0.699. And just like the mean, standard deviation is not resistant. That means that it can be affected by extreme values or outliers. So be aware of that. Okay, I'm going to end the video here for part 1, and we will pick up with part 2 with Z-scores.